Let's look at one of four of these thermostat sections here and see if we can make any sense of how it works. So this is where one of the thermostats will wire, and there are four of those identical circuits throughout the zoning panel. But specifically, I want to talk about this guy right here. So if you've ever wondered, okay, we've got, a microcontroller up here. Sorry about the focus, but we've got a microcontroller up here. And, if you think about it, each thermostat has, let's count it. Let's count it. 1, 2, 3, 4, 5. It's got 5 thermostat inputs, right? But don't forget, we've also got this set of dip switches down here, and these have to do with the weighting of the zone. So if you have a small zone, you can tweak these to accommodate it, and it'll affect the staging of the unit, and as well as the fan speed. It controls both of those things. So technically that's 8 inputs per thermostat, and if there's 4 thermostats, that's 32. That's if you had to monitor all of those inputs individually, that would take up a lot of real estate on the microcontroller. And so in order to avoid that, they used these things right here. Now these things are called analog multiplexers, and they allow you to read all these different inputs and generate a signal that the microcontroller will then interpret in order to figure out, okay, I have zone 4 Y2 calling, Y1 calling, so on and so forth. So essentially these things are like a revolving relay, and we'll look up a data sheet here and we'll talk more about it, okay? Here is a data sheet, hopefully from the manufacturer themselves. Yeah, cool. So let's zoom in here. So the way this thing works is you have actually the C, B, and A. These signals right here, they're actually provided by the microcontroller itself. And they're all going to be square waves, and we'll see this on the scope here in a minute. But essentially C is going to be a certain frequency, and then B will be half of that frequency, and A will be 1/4 of that frequency. And what happens is this will end up creating a binary digit, right? So think about this like binary code. So this would be binary code for 0, binary code for 1, binary code for 2, binary code for 3, so on and so forth until we hit 7. And so as the microcontroller runs, essentially this relay is going to be doing boom. It's going to return, then it's going to do this again, then it's going to return. So it's basically like a revolving relay here. It's being driven by these signals that are incoming from the microcontroller. And our thermostat, 5 of these channels will be inputs from the thermostat. So this might be Y1, Y2, Y3, so on and so forth. And one of these is going to be the dip switches. So we can actually figure all this out in real time, probably. So let's go ahead and power it up. So on the bench here, I have an AC power supply that's variable, and I've wired a line cord. I took a line cord out and wired it to the zone panel, and I have the variac set up here to 27 volts. Alright, so on the scope screen, I've got the GoPro recording it, and we're going to go ahead and cut on this power supply that I just showed you. So when we cut it on, our signals should appear here. And you can see at the top right here, this is the one that I was talking about labeled C. This one's labeled B. This one's A. And then this is the output of the multiplexer. It was the common terminal that all of those relay, like that revolving relay, that's basically the signal that's being created for the microcontroller. All right, I want you to see something cool. Let me go ahead and zoom in to this section of the board. So I'm actually looking at the signal for this one, okay? Now watch what happens to our oscilloscope signal. Watch the bottom one right here. When I cut this dip switch off, one of these is going to go low. All right, so that happened to be the middle one. So that's dip switch number 1. And then dip switch number 2 is right here, and it goes off. So that's the last one there. So that has to be channel 8. So look at this. So keep in mind here that when all 3 of these are low, the multiplexer, if you remember the data sheet, the multiplexer is looking at channel 0 when it's in that case, right? So this would be one of those. I don't think it's high right now, but technically this one, since they're all high, that would be looking at channel 7. So dip switch number 2 goes to channel 7 here. And then dip switch number 3 is going to be channel 5. No, 101. And so 101 corresponds to channel 5, right? And let's do some of the thermostat inputs themselves here. So what I'm going to do is I'm going to unscrew Y3 and Y3 alone. Let's see if we can determine which channel they used for that one. So it's off now, and looks like it, let me put it back so I can see it again. I lost track. Alright, so it looks like that is low, low, high. So low, low, high is channel 1. Alright, and then Y2. Let's see what Y2 looks like. So Y2, let's put it back in. I lost track again. Sorry. So that is low, high, low. So 0, 1, 0 is channel number 2. Now let's take Y1 out. Alright, so which one was that? So that is high, low, low. And so high, low, low is channel 4. Alright, so you can figure out really quickly what all these do. And that is how a zoning panel, at least the way WaterFurnace does it, that is how they're able to take in all these inputs on a microcontroller where you don't have any room. And you can use these for sensors, you can use them for all sorts of things. They are very, very, very useful. All right, so cool. Thank you for watching. Take care. Bye-bye now.